Hey Math 3, so today we are going to look at synthetic division. Synthetic division is a shortcut for long division with polynomial. If you're interested in seeing long division, I'm happy to show it to you during office hours. I just don't want to overwhelm you guys, and you can use synthetic division in this course. So here are the steps. Step 1, you're going to write the 0 in the box, which basically means you're solving the potential factor. Step 2, you're going to make sure that the polynomial is in standard form. So remember, we're going biggest degree to no degree, and all of the degrees are there. So say we're missing like a cube, we're going to put a 0x cubed there. Next step is to write the coefficients next to the box, and this will hopefully make more sense once we start doing examples, so don't get overwhelmed. You're going to bring down the first coefficient, multiply, add, repeat, and then put back the variables. This section is for honors, so we will actually do that at the end of the video, so not everyone has to hear that. Let's go to example 1. So again, I'm going to work on this dry erase board because you guys told me when I do it on the computer, it's a little hard to see. So remember that first step was we want to write the 0 in the box. So if this is my factor, sorry, I meant to grab a different color. If my potential factor is x plus 4, I know when I solve, I set my factors equal to 0. So that means the potential 0 is negative 4. Most of the time, it's just going to mean that you're going to switch the sign and put that number in the box. The next step is to make sure this is in standard form. So biggest degree that I see is this cubed, and I just want to make sure that I'm going 3, 2, 1, none. And I'm looking at these exponents. So when you check standard form, you go biggest to smallest exponent. Now I'm going to take the coefficients, which are the numbers in front, and write them on this line. So there's no number there, so that's going to be 1, 13, 26, negative 25. And notice I did grab the negative. So if there's a negative, you want to grab that negative. Let me try to get out of that glare. All right, then I'm just going to write a line here. And that brings me to step 4. So step 4 says, bring the first coefficient down. So 1 comes down. After this, it's going to go pretty fast because we're just going to multiply, add, repeat. So this box is what I multiply by. So I'm going to do 1 times negative 4, and then I just want to add those, and that's not a very good marker. So add 13 minus 4 is 9. Multiply, add, repeat. 9 times negative 4, negative 36. Add these, gives me negative 10. Repeat. Negative 10 times 4, 40, add 15. Okay, so I brought down the first term, and then I'm just going to multiply with that box, add what's ever there, and then repeat. Okay, so hopefully that made sense. And now I'm going to put back the variables. And normally, it's just 1 minus this. So if I start with a cube, my answer is going to have a squared. But just to make sure, you technically want to do the leading term divided by the leading term in the factor. So x cubed divided by x leaves me with an x squared. So when I put back my variables, this is going to say 1x squared, and then I'm just going to count down. Plus 9x minus 10. This is actually a remainder. So it's a remainder out of the x plus 4 that I just divided by. So you just put your remainder over that potential factor. Let's try another one. So number 2, my potential factor here is x minus 1. So I'm thinking x minus 1 is 0, would give me a potential solution or 0 at 1. So that 1 is going to go in the box. I'm going to make sure I have all of my terms and that they're in biggest degree to no degree, 3, 2, 1, none. So then I'm going to write my coefficients, 2, negative 2, 5, negative 5. Draw my line. All right, step 4, bring down the first number, multiply, add, repeat. So 2 times 1 is 2, negative 2 and 2 gives me 0. 0 times 1 is 0. 5 and 0 is 5. 5 and 1 is 5. Negative 5 and 5 gives me 0. So what's my first variable that I need to put back? Well, I had a cubed divided by a linear, so that would mean I'm x squared. So this term's going to be 2x squared. I have 0x plus 5, and then my remainder is 0. So technically, this answer would just say no x, so I don't need that, and no remainder, so just 2x squared plus 5. The answer before, technically, you don't need that 1 either. I should have told you that. All right, let's look at question 3. So here we go. Question 3. Here's my potential factor, x minus 1. So what minus 1 is 0? 1. So again, 1's going to go in the box. If I put this in standard form, here's where I need to pay attention because I have a 4. I don't see a degree of 3, a degree of 2, a degree of 1. It goes all the way to no degree, meaning no x. So I want to just make this say 0x cubed plus 0x squared plus 0x minus 1. You want to make sure that every degree, starting with whatever the first one is accounted for. So if they're not there, you're just going to put zeros to hold the place. And then when I write these out, I'm going to have 16, 0, 0, 0, negative 1. All right, you guys remember what to do next. I would pause it, try it, and then just come back. All right, so I'm going to bring down this 16, bring down the first one, multiply, add, repeat. 16 times 1, 16, add, repeat. 16, add, repeat. 16 times 1, 16, add, repeat. Oops, sorry, that should be a 16. 16 times 1, 16, add, gives me 15. So I had a degree of 4 divided by a degree of 1. Quartic divided by a linear means that my first term for this one is going to be 3. See, again, it's just 1 less than what I started with. In Math 3, it's normally just 1 less. So I have 16x cubed plus 16x squared. I'm just counting down now. Plus 16x plus 16. And then this time I have a remainder out of that potential factor, which was x minus 1. So it's a really long answer, but that's it. If you are academic, you are free to stop this video. If you are honors, we need to take the second part of these notes. So sometimes in honors, we have an a value that's not equal to 1, like example 4. So if it's not equal to 1 there, we're going to divide by the a and then add a dividing step before we move those up. And I'm going to show you what that looks like. But make sure you fill in your notes that this is not 1, divide by a, multiply, add, put the variables back. All right, let's look at number 4. So here is my potential factor, which means I can't just put a 4 in the box because this is actually saying 3 times what minus 4 is 0. So if I were to solve this one for 0, I would get 3x equals 4. So my potential 0 here is 4/3. So I could put a 4/3 in this box. However, I know students and I know adults, and most of us don't like fractions. So remember, this fraction is just saying divide. That's the a that I'm talking about here. So when I draw my line, I'm going to divide by 3, except for the last one, before I move it up. Other than that, it's the same. So I'm going to keep that 4 in the box and move the divide 3 to here. So still want to put it in standard form, 3, 2, 1, 0, so I don't have to add any terms in here. My coefficients are 3, 23, 6, negative 28. Very similar steps in that I bring down my first term. Now I'm just going to divide. So 3 divided by 3 is 1 before I carry on and multiply. So 1 times this 4 is going to give me 4. Then I'm going to add these 27, divide by this 3, 9, 9 times 4, 36, add what I see, 42, divide by 3 is 14, 14 times 4, I don't know why, but I'm having a little brain issue right now, so that's 56. 56 and negative 28 gives me 28, and you do not divide the remainder. That last slot you don't divide. So now I'm going to read this bottom row and that 28. And I have a cubic divided by a linear, which means my first degree is going to be squared. So I have x squared plus 9x plus 14 with a remainder of 28 out of that 3x minus 4. Again, if you want to see long division, happy to show it to you during office hours. Just don't want to overwhelm you guys. All right, see you guys in class.